Hello, welcome back to the channel. So let's continue our discussion on series and do this problem over here, which is about evaluating the behavior of your sequence when you have some given information about your series. So before watching this video, I'll highly suggest you to first watch my previous video on series in order to get the full idea about this question and this video over here. So we have been given that we have a function f of capital N, and let this function be a formula for the nth partial sum of this series over here. So similarly, like in the previous video, we had a formula for our s of n. So we had a formula for our s of n, and similarly in this question as well, we have been given that let f of capital N be a function, be a formula for the nth partial sum of your series over here. And based on your f of n, you know that your first derivative of f of n, the first derivative for the nth partial sum is less than 0. So your derivative is negative for all capital value of n greater than 1 in this case. And based on all this given information, what can you say about a of n in this case? So this is a simple question over here. It basically uses the concepts of derivatives and relates it to the series case. So we know that since our f of capital N is equal to s of n, and we also know that our first derivative is less than 0, that means if your first derivative, if in terms of functions, if we know that our derivative of a function, our first derivative of a function is negative, we know that that function is decreasing, right? So we know that our f of capital N is decreasing, which also means that if we keep on adding additional terms in f of n, our f of n will have a lower value than the previous value, right? So if you keep on adding extra terms to f of n, which in this case is our nth partial sum, since this is s of n, if we keep on adding additional terms to f of n, we are basically adding the next terms of s of n, right? So adding a of n plus 1, a of n plus 2, and so on. And since we know that our s of n is decreasing, if we keep on adding more terms to the s of n, our sum will decrease. And now we know that if we add more series to our sum is decreasing, which means that we are adding negative terms in this case, right? So if we are adding negative terms in this case, our a of n should be negative as well, right? So the only thing that we can say about our a of n is that it is negative, because this case can only be true when you're adding negative terms to your sum. In this case, you have a s of n sum, and you know that your s of n is decreasing if you add more terms. The only way to make it decreasing, the only way to make your sum a decreasing function is when you are adding negative terms to your sum in this case, right? So that is why if we have to say anything about a of n, we can definitely say that, we can definitely conclude that our a of n is negative. And there's also one additional thing to notice about the condition given in the question, that your first derivative is negative for all values of capital N greater than 1, right? So this means that this equation holds true for all the values of capital N starting from 2, right? So if we know that our sum is decreasing for all values of capital N, when we have at least two values, we can only say our sequence to be negative for all values of small n greater than equal to 2, because in this case you know that your sum is decreasing for all values of capital N greater than 1. So if you have only one value in the sum, in the s of n, if you have s of 1, we don't really know whether that term is a positive term or a negative term, right? That term can be both positive and negative based on this given condition, because this formula, this first derivative inequality, is only valid for all the series which have at least two terms, right? So that is why for capital N equals 1, we don't really know about what that term would be, whether it would be a negative or a positive term. We do not have a definite answer for that. So that is why our a of n is less than 0 for all the values of n greater than equal to 2, So in this question, we related all the concepts about derivatives, first derivatives, and related it with series. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.